Hello class, this is a video tutorial on calculating probabilities from Venn diagrams or two-way tables. So once organized into either a Venn diagram or two-way table, calculating probabilities of events is easily calculated by just carefully adding the regions or the boxes that meet the description. So let's go straight into our first example here. Students in a class wore blazers or jumpers to keep warm for winter. So, as we can see here, just a very quick example, 10 people wore blazers and jumpers, whereas in this one here, 2 people wore no blazers or no jumpers. So first, when we come to probabilities, we should first calculate how many there are in total. In this case, how many students are in the classroom? Well, for this, we can easily and very carefully just add across. This number here tells us how many students wore jumpers. So 10 people wore jumpers, 2 people also wore jumpers. So that's 12. Adding across this way again, 6 plus 2 is 8. Adding vertically, 10 plus 6, 16, 2 plus 2 is 4. Now, when it comes to this point, you should always add both vertically and horizontally because the number here has to match both. So 12 plus 8 is 20, 16 plus 4 is also 20. So this is indeed the total number. So we can say how many students are in the classroom? 20 students. Now from here, a student is randomly selected from the classroom. Calculate the probability the student wears one of the following options: a blazer, a jumper, a blazer and a jumper, and so on. From here, it's just a matter of carefully picking the box that meets the description in the question. So for this, we're looking for the probability of picking a person with a blazer. So we can say probability of blazer. So all we're looking for now is those who fit this description here. So how many people fit this description? Well, just to clarify here, 10 people wear blazers and jumpers. 6 people wear blazers and no jumpers. So in total, there are 16 people out of 20 that wear blazers. So the probability of picking a person with a blazer is 16 out of 20. The probability of picking a person with a jumper, so in similar fashion, we're looking at this row here. So 10 people wear jumpers and blazers. 2 people wear jumpers but no blazers. In total, we have 12 people. So the probability of picking a person who wears a jumper is 12 out of the 20. Now read very carefully part 3 and part 4. It says a blazer and a jumper compared to a blazer or a jumper. Notice how the wording here is very specific. So let's take a look here. Let's take a look at first at blazer and a jumper. So if we were to say pick this box here, this person wears a jumper but no blazer, so we're not looking for this. This person here wears a blazer but no jumper, whereas the 10 here are blazers and a jumper, so we're looking at 10 people for this one here. So blazer and a jumper, so probability of jumper and a blazer is equal to 10 out of the 20. Whereas this next one, its probability of jumper, or, being very careful with the wording here. Now here's where it gets a little bit tricky, because when it says or, it could be an inclusive or exclusive or. If we were to be an inclusive, we're looking at this. So these 2 people wear a jumper and these 6 people wear a blazer. So these 2 are a jumper or a blazer. But this one here, these 10 people wear a blazer or a jumper. In fact, these 10 people wear both. If we were to be an inclusive or, we were to include this one. Now, later on, I'll clarify that a little bit more. But for now, just know that if it's a blazer or a jumper, if it's not specified, we're just looking at everyone that wears a blazer and everyone that wears a jumper and everyone that wears a blazer, as well as those that are doing both. So 10 plus 2 plus 6. That gives us a total of 18 out of the 20. Let's read again. The probability a person wears a blazer but not a jumper. So we'll write this as probability of blazer, comma, not the jumper. So looking at this, those that wear a blazer are this row here, but we're looking at those that also wear no jumper. So 6 out of the 20. Look at the wording on this one. The probability that the person wears only a jumper. So those that do wear jumpers are here. But this person, these 10 people actually, wear jumpers and blazers. But we're looking at people who wear jumpers but no blazers. So that's 2 out of 10. So it's the same as probability of jumper, comma, no blazers. That's 2 out of 10. And lastly, we have the probability of no extra layers, that the person wears no extra layers. Well, no extra layers means no jumpers and no blazers. So that's 2 out of 10 as well. So we can write this as probability of no jumpers and no blazers. That's going to be the 2 out of 20. Sorry, I made a mistake again. That should be 20. Okay, so that's one example that follows a two-way table. Notice how the wording of what we pick is very specific. In the next video, we'll look at calculating probabilities from a Venn diagram. Hope to see you then. Best of luck.